Moving on to the coupling behavior of the same device, you just do not, you just do not reduce the engagement to any percentage. You leave it at 100%, and you use it therefore as a coupling. And in order to do that, or the advantage of doing that, as I mentioned briefly, is to get this desirable situation where where the motor is not being subjected to huge amounts of stress, your mains are not being taxed for a long time, and this is a demonstration of what happened. We used the comparison using the very same motor and load, once with a rigid coupling and the other time with flux drive coupling. And you notice that current at the beginning rises to a very high value. You can't help it. Induction motor will pull that current. But look at how fast current drops to a normal, manageable amount. Within 1 second, current is down to a very small value with the flux drive, whereas with the typical rigid coupling, induction motor goes on to draw a huge amount of current for 9–10 seconds maybe. And during that time, of course, the induction motor is pulling a large amount of power from the supply. So it's not a very transient event after all, as you know. It goes on for 9–10 seconds of heavy draw of power from the supply until the induction motor is done with its starting phase. Whereas with this coupling, as you notice, power drops to a manageable amount for the rest of the time. This is of course possible because of the nature of the coupling, in that it can slip and allow the load to accelerate gradually. But in addition to that, when the induction motor is pulling a large amount of power, notice its power factor is very poor. It's about half. So really, it's causing the power factor of your supply, of the whole building, to drop to a very, very low value, and there are consequences to this. Whereas with the flux drive, as you can see, since the event is over in less than a second, power factor of the motor goes back to its normal level. The motor is running nicely at full speed. Yes, it's being loaded up gradually, but that's fine. It's operating at a very nice, comfortable level of power factor. Okay, there is a disadvantage, I must admit. The induction motor will get the event over in 9 seconds, and that's it. Your pump is running full bore. But with the flux drive, you have to wait another 10 seconds. Okay? That is a disadvantage. You've effectively spread out this violent event of drawing a huge amount of power from 10 seconds to 1 second, but you have to wait a bit longer until your load has reached full speed. This is a freebie, really, from a coupling that can do that and continue to run. Actually, you don't have to do anything. You just continue that way. The slip between the two members is very small, typically from a coupling of this sort. And you notice that something in the order of 2%, which means that the induction motor speed is not reduced by much when it gets to the load. So you're not really losing anything in that transfer of torque from one side to the other of the coupling. But of course, at the same time, you have the coupling permanently there. If something nasty happens to your load, it locks up, for example, your motor is not going to care. Why? Because the coupling will slip and protect the motor. The coupling cannot possibly allow, not possibly, but all right, it won't allow much more than the torque, the maximum torque that it can deliver. And therefore, that's nothing compared to the motor. The load can be damaged, and the motor is still protected because this coupling allows it to travel or slip freely until you get to it or rescue it. Quick word about the comparison between this technology and existing technology. Mr. Coburn referred to eddy current couplings. There are other devices that can do adjustable speed drives. We found reports that detail efficiencies of these other devices, compared them to the efficiencies of this device, discovered that in certain ranges of speed, this device is more efficient, and other ranges of the speed, other devices are more efficient. In other words, we are not, claiming this is a monopoly on high efficiency at all ranges. It's comparable. It depends on the speed you're gonna be operating at, but there are some other advantages that cannot be ignored. This is something about relevant to the type of load we're constantly using in our testing here, which is blowers. And they have this unique behavior that is captured by what they call affinity laws. And these affinity laws say something very interesting, and that is, if you have a blower and you want to cut down the amount of air in half, okay? What you normally do now is maybe block half the fan or do something to cut down that amount. Well, it just turns out that if you need to cut down, let's say, the amount of air in half, then the laws of physics that control the volume of air, the pressure of air, work out in such a way that that reduction of 50% in the volume of air actually ends up reducing your required horsepower to 1/8. Now that has implications on your power bill, because what that means is you can reduce your speed, the speed of that blower, and realize a huge saving in the horsepower that the primary motor is pulling, and achieve the same results while the motor is still running at full speed and is happy delivering that amount of power at its best or near best conditions. And what turns out to be the case is, by experiment, that the behavior of flux drive coupling seems to mirror that desirable curve. One is theoretical and the other is experimental. So this is something that in that particular application is of significant monetary value. I'm going to go through some of the case studies quickly to allow time for some questions. This is a situation at Evergreen State College right here in town where a boiler was giving them constant trouble and in terms of vibration, etc. And this is the old coupling. A new coupling was installed from Flux Drive, and here it is. It takes this very minimal amount of work to install and fits in exactly the same location between the motor and the pump. And the recipient of that exercise is Tony. He's very happy. Apparently, vibrations that have been experienced there for some 30 years have disappeared overnight, and it is in operation right now if you have a chance to visit that facility and see it. If not, you'd have to content it with what you saw last night at the aquarium. Here's the coupling that some of you might have noticed on the floor right next to where it was on the floor, actually sitting here. And instead of that coupling, rigid coupling, a flux drive device or coupling was installed with a handle that is running day and night, which allows the operators there to really control this pump here by just simply moving this handle back and forth, varying the amount of engagement between the two members, and essentially controlling the fixed speed of this motor to deliver a variable speed at the pump. No electrical connections are necessary. The amount of movement is manageable by hand. Of course, it can be automated as you would expect. The review of the performance of the products is fairly obvious, and there are some conclusions here. You can look at them either here or in the paper in your... I don't know where the paper is.
It's posted on the website.
All right, for further details. But